Hi there. Today we're going to go through an overview of the Aqueduct open source project. Aqueduct is a machine learning orchestration layer that makes it easy for you to define an ML pipeline as a composition of Python functions, deploy those pipelines onto any cloud infrastructure that you use, and validate the ongoing quality of your models and predictions as they're running in the cloud. Aqueduct is a pip package that you can install that comes with a Python SDK and an open source server and UI that you can see here. In this demo, we're going to take some data about wine and use that data to make some predictions about the quality of that wine. Using the Aqueduct client, the first thing that we're going to do is load a connection to a database. Aqueduct comes prepackaged to connectors to most common databases, and here we're simply loading a connection to a SQLite database that comes prepackaged with the Aqueduct server. Against that database, we're going to run a simple SQL query that pulls in all of our wines data and puts it into an object called wines. At any point in this workflow, we can call .get on a data object in Aqueduct, which is going to show us a preview of the data right here in our notebook. So we can see here we have a pandas data frame that has the color of the wine, the acidity, the alcohol content, and some pre-labeled quality scores, while some quality scores are missing. In this pipeline, we're just going to fill in those missing quality scores. Now that we have our data, the next natural thing to do is to go ahead and write some functions to transform that data. Here we have two functions, featureize and train and predict. As the names imply, the first function is going to fill in some missing values and featureize some of our data, in this case by one-hot encoding it. And the second function is going to train a decision tree regressor model from the scikit-learn package on our data and use that model to generate some predictions that are put into the predicted quality column. You'll notice that all of the code that's here is just regular Python, pandas, and scikit-learn. The only change we've made is we've added this @op decorator above each function, which the Aqueduct SDK exposes for you. This @op decorator allows Aqueduct to capture the code that you're running, the environment that it's running in, and package that all up to run in the cloud for you. We're going to go ahead and define these functions, and we can call them just like regular Python functions down below. Now with these functions, when we execute them, we'll see that the type of the result that we get in response is an Aqueduct table artifact. A table artifact is a simple wrapper around a pandas data frame that allows Aqueduct to track how the data is moving through your workflow. With this information, Aqueduct can automatically construct your workflow DAG for you without any additional configuration on your behalf. Now that we've defined a pipeline, we can go ahead and publish it to the Aqueduct server. We're going to save our predictions table back into our demo database, into a table called predicted wine quality, and choose to replace the full table on every workflow execution. With that done, all we need to do is call publish flow on the Aqueduct SDK client, give our workflow a name, a description, and a schedule. In this case, we're going to choose to run this workflow daily, and we're going to tell Aqueduct to publish the predictions artifact that we just created on a daily basis. Now, the last thing that we're going to do is see how we can use Aqueduct to gain visibility into the quality of our models and predictions on an ongoing basis. Here, we're going to use the Aqueduct metric decorator to define a function that's going to calculate the root mean squared error of the predictions we just generated. We're going to use the quality labels that we previously showed, compare them to the predicted quality column, and use that difference to calculate the RMSE. On this RMSE, we can also set some bounds using Aqueduct. In this case, we're going to set a soft upper bound of 1.0, which is going to tell Aqueduct that if the RMSE exceeds 1.0, to raise a warning, but continue with the workflow execution, and a hard upper bound, denoted by the severity being set to error, of 3.0. So if the RMSE crosses 3.0, we're going to raise an error, stop the execution of the workflow, and let you know that something's gone horribly wrong. With these changes made, to publish the workflow, all we need to do is simply call publish flow again. This will capture the new RMSE metric as well as the bounds that we set on it, send that off to the Aqueduct server, and ask Aqueduct to execute this for us. With that done, we're now ready to go look at the workflow in the Aqueduct UI. Here we can see the workflow we just created on the Aqueduct UI. We can see that Aqueduct automatically captured everything we wrote in the Jupyter notebook. SQL query, the Python functions, and the data, and renders it as a nice DAG visualization for us here on the UI. At any point in this DAG, we can click into a node to see further detail about it. Here we can see the SQL query we wrote to start the workflow, select star from wine. We can see a preview of the data right here in the browser, and we can also see the code that was executed for any particular function. Additionally, we can also see the values of the metrics and the checks that were created in the notebook. Here we have the RMSE, which is 0.744, which obviously passed both of the checks that we set on it. And we can also click into the metric to see a historical representation of how that metric has changed over time. Of course, this is just toy data, so we don't see any changes here. And that's it. To learn more, check out our open source project and our website, and let us know what you think. We'd love to hear from you.